Dr. S. Balakrishnan is working as polymer consultant and visiting faculty in the area of polymer science and chemistry. He has completed BSc at Arinjar Anna Government Arts College, MSc at Ramakrishna Mission Vivekananda College in Chemistry under the University of Madras, ME in Polymer Technology at Delhi College of Engineering, University of Delhi, and PhD in Polymer Engineering at IIT Madras. He has worked for 3 years as postdoctoral scientist at Polymer Division, Howard University, Washington, D.C., USA. He has worked as Senior Research Engineer for 2 years at Institute of Microelectronics, Singapore, and as Assistant Manager Polymer Division for 3 years at Precol Limited, Coimbatore. He has also worked as Polymer Consultant with Skyline Resins and Chemicals and other firms for 4 years. He is having 8 years of teaching experience in polymer science and chemistry in SIPAT, Chennai and Karpaga Vinayaka College of Engineering and Technology. He has published 16 research papers in peer-reviewed journals and presented more than 25 papers in national and international conferences.
Welcome viewers for the UGC program on polymer science. We are looking polymer blends and composites subject. In this episode, we will be seeing polymer composites, classifications and matrices selection criteria. Contents of my talk: introduction to composites, classifications of composites, selection criteria of polymer matrices for composites, applications of composites. So, in this slide we can see how the importance, the list submitted by and adjudged by American Academy of Engineering top 10 engineering achievements of 20th century. In this list, if you see the first, moon landing; second, applications, satellites, weather communications; CAT scan; fourth, microprocessor; fifth, lasers; six, CAD and CAM; and 7 if you see advanced composites materials invention, and 8 jumbo jet, 9 and 10 other things. So, this list is adjudged by the American Academy of Engineering. So, the polymer composites or advanced composites and polymer composites in particular finds 7th place among the top 10 engineering achievements of the 20th century. So, the composites material that much importance in this advanced technological arena. So, composites, a formal definition, consists of 2 or more physically distinct and mechanically separable parts. Constituents can be combined in a controlled way to achieve optimum properties. Properties are superior and possibly unique compared to those of the individual components. So, this is a definition, mainly the constituents, mainly matrices, matrix and reinforcement combining such a way the resultant composites shows superior performance characteristics, although constituent material is not the case. So, conventional man made composites, historical, if you see the composites historical things, bricks with a straw, it is something 3000 years back. Egyptian used to make wall or some purpose, bricks with a straw reinforcement, and mud wall with wooden crumbs, this also common practice in olden days. See something related to reinforcing some hard material in the to get the most strength. Recent functional composites in the mundane applications, cement concrete, asbestos cement, plywood, these are all something recent functional comes under composites materials family. So, this composites topic, if you see that, so nature also makes for millions of years from the since earth is started and life is started on the earth, this composites kind of thing, natural composites is being made by nature. Nature has been making composites for millions of years and is the best creator of composites. Examples: wood is a composite, bamboo, bone, skin, muscles, shell of beetle, horn of rhino and coconut husk. So, all these strong materials some way they are all composites made by nature. So, nature biologically grows composites, we have yet to learn this route of manufacture. So, nature this kind of composites using dissimilar material combining in such a way getting the highly performing composites So, its nature is already is making for millions of years. So, now we come to the topic of our interest, advanced composites. Advanced composites are modern man made high performance materials created using cutting edge technology and scientific principles. So, the history of advanced composites started with the development of glass fiber by Owens Corning fiberglass in USA in 1938 and polyester resin in 1936. So, the first glass polyester composite laminate was made in 1942. So, this they mixed the glass fiber and polyester resin. So, that is a starting of the composites started in 1942. So, this is the origin of the advanced composites. So, classifications based on three mode of classification we can see in this presentation. First, classification based on level of composition dimensions. One is macro composites. So, macro composites means the inserted constituent is of size 1 millimeter or above, example the cement concrete. In this aggregate in the size of 1 millimeter may be higher order mixed with cement. So, that is also example of composite comes under the category of macro composites. Second, cement comes under the category of macro composites, and micro composites we see that inserted constituent is of the micrometer size, example glass fiber. Glass fiber is in the order of around 5 to 10 micron size diameter, glass fiber single filament diameter. So, glass fiber polyester composite comes under the category of second category micro composites, and third nano composites, nanoparticles fibers are inserted into the matrix. Most natural composites are nano composites. So, these are the three composites classification based on the reinforcement dimensions in the matrix. If you see the second type of classification of composites based on matrix used, one is polymer matrix composites. Polymer matrix composites two types, one reinforced thermoset composites, two subclass reinforced thermoplastic composites. So, out of these first one is reinforced thermoset composite is very important in the polymer matrix composites. Second category metal matrix composites, so and third ceramic matrix composites. So, now the detailed classification based on reinforcements, different type of reinforcements, the composites classified particle reinforced, fiber reinforced and structural composites. So, if you see the particle reinforced composite, so large particle dispersion strengthened. So, this particulate type may be micron, macro size may be more than 1 millimeter, flakes kind of particulates mixed with, and this comes under particulate composite. Second, fiber reinforced subdivided into two continuous fibers aligned in one direction, discontinuous short fibers, two types. So, continuous fiber and discontinuous fiber, two under the fiber reinforced composites. Further, this discontinuous short fiber composite divided into two aligned in one direction, randomly oriented. And if you see the third class of fiber composite classification, structural composites, so example laminates, sandwich panels. So, these are the advanced composites is made in all these different categories. So, this is the detailed classification in particular about the advanced composites. So, we can see now the components in a composite materials. We are understanding about the components. Nearly all composite material consists of two phases. One is called primary phase, forms the matrix within which the secondary phase is embedded. Secondary phase, embedded phase, sometimes referred to as a reinforcing agent. So, this is a reinforcement, different type of reinforcement when it is embedded in the matrix produces high performing material called composites. The reinforcing phase may be in the form of fibers, particles or various other geometries. So, polymer matrix materials, we can see detail about the polymer matrix which is used to make the polymer reinforced composites. So, there are two basic categories of polymer matrices, one thermoplastics, two thermoset plastics. So, out of these thermoset plastics is most widely used to make the polymer matrix composites. Almost 90% of the polymer composites you made using the thermoset plastics. Roughly 95% of composites market uses thermosetting plastics. Thermosetting plastics are polymerized in two ways: by adding catalyst to the resin causing the resin to cure. Curing may happen at room temperature or by heating the resin to its cured temperatures. So, thermoset resin curing may happen at ambient condition, depends on the type of resin and catalyst system, or depends on the other resin, it may the curing may happen at a higher temperature, depends on the resin system. So, polymer matrix materials, common thermosetting plastics. So, here most three most common thermosetting plastics: phenolics, second epoxies, third polyester. So, out of these thermoset resins, polyester is foremost important, large almost more around 90% of the thermosetting polymer matrix composites made using polyester resin. So, that much important. So, phenolics mainly based the polymer matrix composite mainly used electrical applications and high temperature applications. Epoxies based polymer matrix composites is used in high end applications like aerospace, space applications and defense applications, chemical resistant application, temperature resistant application kind of applications. Polyester resin is most versatile, different grades are available. It is used from starting from ordinary applications to housing, construction kind of applications to automotive, transportation kind of applications. So, reinforcement fibers, we can see what are the functions of reinforcement in the polymer matrix composites. Main function is to improve mechanical properties, that is the main function for which polymer matrix composites are made. To alter functional properties, to give directional properties in composite products. Materials for fibers, examples, what are the type of fibers are used in polymer matrix composites. Fiber materials in fiber reinforced composites: one, glass fiber, most widely used reinforcement in polymer matrix composites. Second category, carbon, high elastic modulus, mainly high end and high tech applications. Boron, some specialty applications, and then fourth, polymer based reinforcement, Kevlar fiber, that is also high tech applications is used. So, these are the commonly used different type of reinforcement fibers in polymer composites. The most important commercial use of fibers is in polymer composites. So, matrix resin selection criteria. So, what are the basis how the resins or matrix resin is selected for different polymer composite applications, we can see that. So, those requirements are then translated into four main criteria. One, the four main criteria considered for selecting polymer matrix: one, performance, weight, service condition, cost. So, these are the four main criteria considered in selecting polymer matrix for different applications. 7 sub criteria: one, tensile strength, Young's modulus, impact strength, density, resistance to water absorption, raw material cost, material processing, melt temperature. So, these are the 7 subclasses considered in selecting polymer matrix for composite applications. Some more selection consideration, this some more detail polymer matrix. So, the interlaminar shear strength is an important design consideration for structures under bending loads, whereas in plane shear strength is important under torsional loads. Depends on the end use what kind of load the product is subjected. So, that is also taken into consideration, whether product is mostly subjected to requirement shear strength, interlaminar shear strength or in plane shear strength. So, based on this also consideration important consideration in selecting the matrix. So, selection of matrix has a major influence on the interlaminar shear as well as in plane shear properties of the composite materials. So, interaction between fiber and matrix is also important in designing damage tolerant structures. So, the matrix provides lateral support against the possibility of fiber buckling under compression loading, thus influencing to some extent the compressive strength of the composite material. So, here the chosen matrix material should have very good interaction with the reinforcement. So, that this kind of objective could be met. So, finally, the processability and effects in a composite material depend strongly on the physical thermal characteristics such as viscosity, melting point and curing temperatures of the matrix. So, this matrix characteristics, processability characteristics like viscosity, melting point, curing temperature is also considered in selecting matrix for the polymer matrix composite applications. So, addition of properties. So, the glass and polyester. So, glass most stronger and polyester resin chemical resistant. So, combining these lead to glass reinforced plastics. So, the strength and chemical resistance is merged in this resultant product. Apart from that, the unique properties achieved when we are mixing glass fibers and polyester resin in making glass reinforced plastics. So, the initially inherent nature of brittle characteristics of both glass fibers and polyester cubed polyester resin both inherently brittle, whereas the resultant composite glass reinforced plastics tough, that is a very secret behind the success of composites in different applications. The resultant composites lead to tough, high impact strength and high fracture strength, fracture toughness. So, that is the basis. The composites are very interesting and useful material. So, composites processing, composites are created during the product manufacture by mixing reinforcement and matrix in proper proportion and processing technique. Composites manufacturing can involve both physical and chemical changes. During manufacture, both changes may happen in making composites. Composites are made by molding and not by machining, hence there is no wastage of materials in production compared to conventional fabrication technique top down approach. So, the basic features of composites, there is no chemical reaction between the constituent materials as in compounds. So, there must be good bond between materials to work together. Although there is no real chemical reaction between the matrix and reinforcement, but the good bonding need to be ensured in composites. Composites are bonded mixtures. So, these are the some important features about composites. So, we can see the example, the commonly used composite product helmet. Helmet made of glass fiber and polyester resin is an example of good partnership. So, both glass fiber polyester are brittle and less impact energy under shock loading. However, the two together as glass reinforced plastic can have its impact resistance increased several folds, absorbing the energy, shock loading energy by developing numerous micro cracks, preventing the shock from transmitting to the head and brain. So, this is a mechanism, this point highlights what kind of mechanism, how the shock loading resistance is attributed in the composites. So, the mechanism is here. So, when the shock load is subjected, so the shock load is absorbed by the product composite product developing numerous micro cracks. So, that is a mechanism involves the basis for the high fracture strength and high impact strength. So, this composite process also permit helmet to be molded in correct shape and it is also lightweight. So, these are the one important fact about composite, why and how the impact strength is and fracture toughness is high in the case of composites. So, some of the pictures we can see what type of reinforcements type is made available for making composites. So, here we can see the left hand side picture, the carbon fiber and glass fiber rovings. So, and then the right hand side picture close up of a roving glass fiber roving. So, how it looks like. So, roving and filaments and kind of glass fiber reinforcements made available using this. So, different type of processing techniques polymer composites are fabricated. So, here some more picture, the chopped strand mat and woven roving mat glass fiber, how is made available commercially for making polymer composites using polymer resins. So, this picture shows commercially available carbon fiber based reinforcement. Carbon fiber woven fabric is also like glass fiber, woven fabric is made available based on the carbon reinforcement, carbon fiber reinforcement for the making the composite applications. So, so far we have seen the micro reinforcements, carbon fiber, glass fiber. Nowadays, something to get some advancement in the composites, nano based reinforcements is also being used in selective applications. Examples of nano reinforcements: nano clay, montmorillonate based nano clay, carbon nanotube, graphene based nanomaterials, nano reinforcement, nano silica, nano OS, and this is also another clay type nano reinforcements. So, these are some of the examples nano reinforcements is available for making some special nano composites for different applications. So, advantages of composites, particularly construction applications, important points: aesthetic appeal, ability to mold complex shapes, various surface finishes available, lightweight, durability and corrosion resistance, parts integration, cost effectiveness, electrical properties. So, these are the host of advantageous properties due to these composites find in engineering applications, particularly construction applications. So, something how the importance composite material compared to other materials, conventional materials. So, you can see in this slide. So, even on a global level, composites production 5.5 million tons is very small compared to 1450 million tons of steels and 900 million tons of aluminum used. So, the quantity if you see some looks less compared to steel and aluminum. So, there are about 200 families of composites and about 100,000 products are being made. So, although quantity is less, but different families or types of composites and 100,000 products are made using composite material. So, its versatility and some specialty applications. So, that we can see here. So, the details applications of composites, commonly these composites are used applications like roofs, canopies, complete buildings, cladding panels, masts and towers, domes, unusual architectural features, structures, radomes, permanent and temporary formwork, strengthening, repair of conventional structures, tanks, covers, pipes, ducts, etc. So, these are the commonly most this kind of applications polymer composites are used. So, if you see the picture, so in India application of composites in India. So, the important sector, so electrical and electronics about 30% composites are used in this sector, buildings and construction about 20%, and then third segment chemical and corrosion resistant application 20%, fourth transportation, land transportation, bus, trains, kind of automotives 15%, and defense and aerospace 2%, others about 8%. So, these are the various sectors in which polymer composites are being used in India. So, some interesting applications about polymer composites in aerospace applications, the type of components, aircraft frame components, accessories, fuselage, rudders, missile components, nose cones, rocket, motor casings, re-entry modules. So, kind of applications, aircraft and space applications, polymer composites common finds applications. And then the mechanical engineering, mainly transportation applications, automotive and railway components, transmission shaft and flywheel, fan impellers, cooling towers kind of applications, these polymer composites find applications. So, at the end of this episode, so you can see the summary of what we have seen in the polymer composites classifications and selection criteria. One, important terms, definitions and history of composites we have seen. Classifications based on dimensions of reinforcement, matrix types and reinforcement types. So, classifications we have seen. Selection criteria of polymer matrices for composites applications we have seen. Properties of composites we have seen, and various applications polymer composites usage we have seen. So, and also we can see sample questions in this episode. 1, write briefly on natural composites. 2, what are important features of modern composites. 3, write on classifications of composites based on reinforcement dimensions, types and matrix types. 4, what are the selection criteria for polymer matrices selection for composites. Thank you viewers.